Hey everyone, and welcome. So have you ever been driving down a street and noticed how some are just perfectly, evenly lit, while others are a total mess of bright spots and super dark patches? Well, that difference, it's not about how powerful the lights are, it's about how they're designed. Today, we're pulling back the curtain on one of the most critical concepts in outdoor lighting, ISNA distribution types.
So, let's just get this out of the way right now. When it comes to lighting, is brighter always better? I mean, it's a common thought, right? Just throw more power at it, crank up the wattage, and problem solved. But as we're about to find out, that could not be more wrong.
Because here's the real secret to amazing lighting. It's not about raw power. It's all about control. It's about putting the exact right amount of light precisely where you need it, and, just as importantly, keeping it away from where you don't. That's the big idea we're going to unpack today.
So, here's our game plan. We're going to start with the basics, moving beyond just brightness. Then we'll dive deep into the IESNA distribution types, the real stars of the show. After that, I'll show you how to read the data that actually defines these light shapes. And finally, we'll bring it all home and see how you can take this theory and apply it to a real-world project.
Okay, let's jump right in. To really get a handle on lighting design, you've got to speak the language. And that conversation always starts with distribution.
So what is light distribution, really? Well, put simply, it's the shape, or the pattern, of light that a fixture, or a luminaire, as we call it in the industry, casts on the ground. And let me tell you, getting this right is everything. It's the key to efficiency, to safety, to visual comfort, and even to cutting down on that annoying light pollution, that glow you see over cities.
The IESNA system breaks this down into two main directions. Think about it like you're watering a garden with a hose. The lateral throw is how you sweep the water from side to side, covering the width of your garden. The longitudinal throw? That's how far you can shoot that stream of water forward and backward down the path. These two directions are the building blocks for everything else.
And this is where the rubber really meets the road. That longitudinal throw directly impacts how far apart you can place your light poles. See? A light with a short distribution means you have to place those poles much closer together. But a fixture with a long distribution, well, that can punch light way down the road, letting you space those poles out up to 6 times the mounting height. You can imagine what that does for project costs and the overall look of a street. All right, now for the main event, the 5 lateral distribution types. These are the standardized shapes defined by the Illuminating Engineering Society, or IESNA, and they are basically the fundamental language for describing how a light behaves outdoors.
First up, we've got Type I. The easiest way to think about this one is as a long, skinny rectangle of light. It's designed to throw light forward and backward in a really tight line. It's absolutely perfect for things like walkways or bike paths, where your only goal is to light the path itself and not waste a drop of light on the grass on either side. Next, we have Type II. Now, this pattern is a bit wider than Type I. It starts to push a little more light out to the sides. You'd use this for slightly larger spaces, like a quiet 2-lane neighborhood street or a really wide walking path where you need to light the shoulders too.
And here it is, Type III. This is often called the workhorse of roadway lighting, and for a very good reason. It's hands down the most common type you'll find out there. It has this fantastic wide forward throw that's just ideal for bigger, multi-lane roads and most parking lots. It just strikes this perfect balance of pushing light down the road and across the road. Type IV is a specialist. Its design is pretty unique. You mount it on the side of a building or at the very edge of a property, and its whole job is to throw light forward in a big, wide semicircle away from whatever it's mounted on. This is your go-to for perimeter security because it prevents that annoying backlight from spilling into windows.
And last but not least, we have Type V. Unlike all the others, this one is perfectly symmetrical. It just casts a big, uniform, circular, or sometimes square pattern of light all around. This is what you use when you've got a pole in the middle of a huge open area, like a big intersection or a parking lot island, and you need light to go out equally in all 360 degrees. So, we know the 5 types, but how does the designer actually see these shapes before a single light fixture goes up? Well, that is where photometric data comes in. You can think of it as the light's blueprint. This data is packaged into a standard format called an IES file, and honestly, the best analogy is that it's the luminaire's unique DNA. It might sound complicated, but it's really just a simple text file. But inside that file are thousands of data points that map out the light's intensity at every conceivable angle. It's the raw code of the light. And then we visualize that raw data in one of two ways. For what we're talking about today, roadway and area lighting, we mostly use a polar diagram. It's perfect for seeing the actual shape of the light. Now, for things like floodlights, we are just focused on a single beam. A Cartesian diagram is often better because it just lays everything out on a simple XY graph.
Now, this might look a little intense, but what's so cool is how much you can tell just by glancing at one of these. Let's break it down. First, symmetry. If you see two different curves, you know the light is asymmetrical. It's throwing light differently in different directions. The direction the curve bulges out, that's telling you exactly where most of the light is going. Those circles are like a topography map for light intensity, measured in candelas, getting weaker as you move out. And the beam angle? That's simply the point where the light's intensity drops to 50% of its peak. It's a complete performance map in one little picture.
Okay, so this is the real question, isn't it? We know the types, we know how to read the data, but how does this all come together in a real-world successful lighting project? Well, it's a pretty clear, logical process. First, you figure out your application. What are we lighting? A quiet path? A busy highway? Second, you look at the site itself, the geometry. How wide is the road? How high can the poles be? And how far apart do they need to be? Third, based on that, you pick the IES type that best fits the job. And finally, and this is absolutely crucial for any professional, you verify your choice. You take that IES file, plug it into simulation software, and get a virtual preview of exactly how it's going to look.
And here you go, a little cheat sheet to tie it all together. A narrow path gets a Type 1 to keep that light focused. A standard 2-lane road? Perfect for a Type 2. A bigger 4-lane road needs that wide coverage from a Type 3. Lighting up the edge of your building? That's a Type 4 job all day long. And for that huge open parking lot, you'll want a Type V sitting right in the middle, giving you that 360-degree coverage.
You know, knowing this stuff is also how you avoid some really common and, frankly, very costly mistakes. The number one sin in lighting design is picking a light based on its wattage instead of its distribution. Another is totally ignoring how mounting height and pole spacing are linked. Mismatching the type, like using a narrow Type 2 on a wide road, gives you that awful zebra stripe effect. And using a Type 3 next to a building, you're just blasting the wall with light that a Type 4 would have easily prevented.
So look, if you take just one single thing away today, let it be this. Great lighting design is not about brute force. It's about control. It's about shaping the light with elegance and precision to serve the space. So the next time you look at an outdoor light, don't just ask, how bright is it? Ask, where is the light going? Because that is the question that really, truly matters.